Okay, welcome back to this lecture. In this lecture, we are going to revisit example 35 that we did in chapter 2. In example 35, Dr. van Rooyen was setting up a private medical practice. She required a loan of 500,000 rands, which was secured from a local bank at an interest rate of 18% per annum compounded monthly. The budget allowed for equal half-yearly payments of 80,000 rands. The first payment fell due exactly 6 months after securing the loan. And then in example 35, we calculated the number of payments required to settle the debt as 9.818 half-yearly payments. And of course, we could not leave it at 9.8. It has to be an integer. So therefore, we rounded it up to 10 half-yearly payments. Now, we intuitively feel that the last payment should actually be less than 80,000 rands. So in this example, we would like to calculate what that final payment should be. We know that that final payment must be less than 80,000 rands, and we would like to know what that final payment should be. Now, there are two methods. We can solve it in two different ways. But the basic idea is that we will move the value of the payments all to the same point in time and then set it equal to the value of the original loan at that point in time. So in example 38, we are now going to solve this. Perhaps we can just start by writing down all the important formulas that we will need to solve this example. Now, first of all, because it's a complex annuity, we will have to find the equivalent effective interest rate. Okay, so we have four formulas here. The first one is to find the equivalent effective interest rate. The second one is to find the present value of an annuity. The third one is to find the future value of an annuity. And the last one on this slide is the future value for compound interest. Okay, so if we look at this timeline of ours, she borrows a loan, or she borrows an amount of 500,000 rands. Then she makes 9 full payments of 80,000 rands each. And then the 10th and final payment we will indicate with a capital F. And we want to calculate what that final payment should be. At this stage, we know that that final payment must be less than 80,000 rands. So the first method would be to move all the payments to time t0 and then set it equal to the 500,000 rands at time t0. Now, if you look at the full payments, the 9 full payments of 80,000 rands each, then we are working with an annuity. And then if you look at the final payment, we are working with a single amount. Now, we would like to move the annuity to time t0, in other words, to calculate the present value of the annuity. And then we would also like to move this single amount, the final payment, which is a single amount, we would also like to move that to time t0. Okay, so we can now say that the loan at time t0 is equal to the present value of my annuity plus the present value of my final payment. Okay, now the present value of an annuity we have that formula here on the previous slide. And to get to the interest rate that we want to use here, we want to find the equivalent effective semi-annual interest rate. So let's first calculate that before we continue with this example. We actually did that when we did example 35, but for revision, let's just quickly do that again. So I want to find and I'm just going to do it here. I want to find equivalent effective semi-annual interest rate. So that will be 1 plus my effective monthly interest rate, which is my 18% divided by 12. So that is just 0.015. My M is 12. My P is a 2. And that gives me okay, so that is the interest rate that we are going to work throughout with. So to get back to this part here, my 500,000 rands is equal to the present value of my annuity. I use the formula for the present value of an annuity. My payment is 80,000 rands. And now for my interest rate, I use this one here. I'm not going to substitute, or rather, I'm not going to write out all the decimals, but you should do that when you do your calculations, because it's important for those decimals to be part of the final calculations. And my K here is equal to 9 because I've made 9 full payments. Okay, so that is the present value of the annuity, and then we want to calculate the present value of the final payment. Now, because it's a single payment, we make use of the formula that we used in chapter 1. We want to find the present value of a single amount. So my final value in this case is my F. So my final value or future value is F. And I move it back 10 time points to time t0. So therefore I take it to the minus 10. Okay, let's just continue on the next slide. Now, if you do those calculations, you get that 500,000 is equal to times my final value. So to be able to find my final value, I will subtract this value here from my 500,000 rands and divide it by the 0.4. And that, if you do that, you should get that your final payment is equal to 66,019 rands. Okay, so that was the first method to find the final payment. We can, of course, get this, the same answer by moving all the payments to time t10. So if we go back to our timeline, for this first one, we moved all the payments to time t0 and set it equal to 500,000 rands. So what we can do next is we can move all the payment, or we can move the original loan, this 500,000 rands, we can move that to time t10 and set that equal to the value of the annuity at the time t10 plus the final payment. Okay, so to do that, we will take the 500,000 rands and we move it to time t10. Again, I'm not going to write out all the decimals. I move it 10 time periods forward. So this is a single amount that I move to time t10. That is why I make use of this formula here. Okay, and that is then equal to the value of my annuity at time t10. Now remember, my annuity goes from t0 to t9. So if I calculate the future value of the annuity, it will give me the value of the annuity at time t9. So I have to get the value of the annuity at time t9 and then move that value, future value of the annuity, move it to time t10. So first of all, I will use this formula here to get the future value of an annuity. So let's do that in blue. The future value of my annuity is the payment. And I have 9 payments. And that gives me the value at this point. But now I have to move it another time period. And the future value of the annuity is a single amount. So now again, I use this last formula to move it one time period forward. Okay, and then of course the value or the final payment is already at time t10, so that is just plus my final payment. So now you can go and do the calculations. Okay, and if you subtract this from this, you get the value of your final payment. Okay, and it's very similar to the answer we got for the previous method. If there are differences, it's just because of rounding off. Okay, so in this lecture, we revisited example 35 and we looked at 2 different ways or approaches to calculate the value of the final payment. And yes, of course, this final payment, 66,000, is less than the 80,000 rands.